Reassessment of standard 9.1. A string is wrapped around a disk of mass 2.1 kg. Its density is not necessarily uniform. Starting from rest, you pull the string with a constant force of 9 Newton along a nearly frictionless surface. At the instant when the center of the disk has moved a distance 0.11 meter, your hand has moved a distance of 0.28 meter. The figure is shown, and my hand is pulling the mass with force of 9 Newton. Let x equals 0.11 meter and d equals 0.28 meter. At this instant, what is the speed of the center of mass of the disk? Using the principle of conservation of energy, work done equals change in energy. Work done is the product of force and displacement, so Fr equals change in kinetic energy, which equals final kinetic energy minus initial kinetic energy. Force 9 times displacement 0.11 equals final kinetic energy, which equals half into 2.1 times final velocity square minus 0, since initial kinetic energy is 0, and which gives final velocity 0.97 meter per second. At this instant, how much rotational kinetic energy does the disk have relative to the center of mass? Considering the disk as a point particle system, change in energy of system equals work done by the surrounding. Change in energy of system equals change in translational kinetic energy, which equals work done by the surrounding, and work done by the surrounding is the product of force and displacement, so change in translational kinetic energy equals Fx. Considering as a real system, change in energy of system equals work done by the surrounding. Change in energy of the system is the sum of change in translational kinetic energy plus change in rotational kinetic energy. So change in translational kinetic energy Fx plus change in rotational kinetic energy, which equals F, and the sum of the distances x plus t. And solving this, we get rotational kinetic energy F equals 9 into 0.28, which equals 2.52 joule. At this instant, the angular speed of the disk is 7.5 radian per second. Moment of inertia, find the moment of inertia of the disk. Rotational kinetic energy equals half times moment of inertia times the square of the angular speed. And rotational kinetic energy, which we found 2.52 joule, equals half I times the square of the angular speed 7.5 square, and which gives moment of inertia 0.0896 kg meter square.